Hello, everyone, and welcome back after that little 1 minute break. Just had a stunning conversation or presentation by Lionel, despite the technical difficulties and all that. And next, we have Dr. Eric Newby, head of product at ecosystem.Ai, who's going to speak about the human in the system. And Eric, that's anything that's got to do with humans when it comes to this technology is fascinating to me. So it's nice to see you, and we look forward to hearing what you have to say.
Thanks, Jan. I'm going to be talking about what happens when you have a human in your AI system and some approaches that we've found to be particularly helpful when there is a human in the system and you have to work with that fact. So I think the starting point is globally there's a large and growing focus, as we all know, on using AI in systems where there are people involved to understand customers, systems, employees, and there's so many facts sort of illustrating this, but just for a bit of context, it's projected that by 2025, 90% of customer interactions will be supported by AI. Today, 66% of customers already expect companies to understand their unique needs and expectations. And in terms of organizations and employees, 14% of companies are already using AI to engage with their employees. So having AI with the human in the system is something that we're moving towards and that people are already trying to optimize, but it gets really complicated because AI and people are both evolving at a rapid rate, and it's hard to keep up. And this is driven by three key forces that you need to try and overcome if you want to deal optimally with the human in your system. So the first is that the way that humans behave depends heavily on the context that they're in and their history. And context and history are changing all the time. So you need to have an understanding of this context in order to engage with people in an optimal way. And to get that understanding, you need to be able to have frequent experiments and redeployments to keep up with the ever-changing present and keep on top of what context your human is interacting in. But that gets really difficult because of the second factor that exists, which is that AI and machine learning are hard to deploy already, but the space is evolving all the time. There's new packages coming out. There's new models being developed. If you look at the number of papers published every year on artificial intelligence, it's still sort of growing at an almost exponential rate. And the complexity of deploying any solutions is growing commensurately with that. You can see that coming through in the fact that more than 50% of machine learning deployments fail. And of those that do succeed, 60% take more than a month. And that really isn't fast enough to keep on top of the context and history of the humans that you're interacting with. And finally, there are insights into human behavior from social science going largely unused. So, social science as a field is based around sort of studying and observing human behavior. And in particular, there have been rapid and significant advances in the study of human behavior in the emerging field of computational social science. But it's really difficult to incorporate these insights and this research into a machine learning pipeline. They just don't naturally meld together. So you're leaving a lot of expertise on the table. So the question is, how can you deploy predictions easily, rapidly, contextually, and with behavioral research and insights? So we found in building our product that there are three sort of key areas that you need to bring together in order to achieve this. And for the rest of the talk, I'm going to go through a few things that we found particularly useful and impactful across each of these areas, and that we've tried to build into our product to enable this to sort of be spread across many organizations to help them engage with the human in their AI system. So the first area is you need to know and enable rapid deployment of real-time machine learning models. The second is having an understanding of computational social science and behavioral economics and integrating those into your product and process. And finally, you need to know how and have experience, know how to and have experience modeling computational systems and organizational structures, and again, integrate those into the product that you're offering. So obviously each of those is sort of an hour's talk at least on its own, but just to give you a taste of it, we'll talk through a few key pieces in each of them. So in terms of deployment, we found that having a flexible worker architecture, enabling sort of rapid integration of new technologies and packages is very important. Having model enablers that allow a model to be more immediately practically useful in a production environment. And finally, having a modularized approach for your prediction use cases to allow you to scale and deploy things in a more rapid cycle is also very important. So the worker architecture, so it's nice refreshing. So this is just a view of sort of our architecture, but to illustrate sort of the work architecture principle. The idea, like I said, is that you need to architect your system in such a way that it's easy to integrate in any new packages or algorithms that are developed. So if a new deep learning package is released and it becomes the package of favor of the day, you need to be able to integrate that into your system. And we sort of split our architecture into two areas. The first above that red line is our training architecture, and below it is the in production scoring architecture. And for both of those, you need to be able to integrate these new packages. So you need to be able to both train a model in this new package and then deploy it in your production environment. And another important thing is that production environment needs to be very resilient, very lightweight, and very fast. We find that when interacting with humans, generally the point where you most want to expose your predictions to them is a key point in the customer journey. And any company is going to be reluctant to let you interact with that customer journey if they think you're going to break the process because your model crashes, or you're going to slow it down because you take half a second to return a result rather than sort of millisecond response times. So having that flexible architecture to allow you to incorporate new packages is very important to keep up with the evolving AI landscape. Second thing around model enablers is we've seen that deploying just a model in production is generally not very useful. You need a range of extra functionality around it. And if that needs to be developed in a custom way every time, it slows things down a lot. So the idea is to package individual modules that have sort of generally useful functionality. As an example, a budget tracking module is very useful if there is any sort of cost associated with your predictions. If you're giving people offers or vouchers and you want to, one, not exceed your budget, and also shift the predictions around as your budget reaches certain thresholds. Say you only want to offer 10% of your budget towards a certain voucher type, you need to be able to have that functionality easily available. And there's sort of a range of other things around whitelisting, multi-on bandits, being able to choose between different models based on conditions, stringing together a bunch of different models to achieve an overall result. All of that needs to be easily available to enable quick deployments. And then the third piece is around having a modular approach. So once you've built a prediction use case out, it's very useful to be able to store that as configurable metadata and share that either across countries or across divisions in the organization to allow for rapid deployment of similar types of models. So you would put that on top of a machine learning platform and then use your metadata to quickly deploy models across different areas. So the next thing that you need to focus on getting right is an understanding of computational social science and behavioral economics. So again, there's a lot here, but two things that I think are just kind of interesting to give you a taste of it is building out behavioral features. What we mean by that is taking clients' interactions with you, and using that data to expose their underlying behavioral characteristics. And the second that we're going to talk about briefly is real-time context monitoring, so keeping track of the situation that your humans are existing in. To just make the behavioral features a bit more real, I thought it would be cool to talk about a specific example. So one that we found quite powerful in a range of different industries is building out measures of customer personality. You need to do two things to do that. The first is develop a personality construct. So what do you mean by personality? What are the different types of personalities that you're dealing with? And the second is develop hypotheses for finding indicators of that personality construct in your data. Obviously, this goes beyond the sort of normal data science areas of expertise, and you need to have quite a cross-dimensional team to pull this off. Sort of expertise from social science, psychology, computational social science, and obviously data science is key as well. And if you bring all of that together, it enables you to achieve these two steps. To give sort of an example of how it can work, a personality construct that we have found to be quite useful. Sorry, this slide is just taking a while to load for some reason. Let's give it a second. Cool. So this is just an illustration of one of the constructs that we've found to be quite useful for a range of companies, and that we can find meaningful indicators of in the data. It's based at the base level off an introvert-extrovert split, and everyone sort of gets a scale across every different measure. So no one is exclusively introvert or extrovert. You exist on a scale. And then we have two ambivert personality scales, industrious and enthusiastic, and then one sort of extreme introvert scale, intentional, and one extreme extrovert scale of experiential. I'm not going to go into exactly what all of those are given the time constraints, but you can sort of figure out from the names how those different personality scales would behave. And then what's sort of interesting is then trying to find indicators of that personality construct in your data. So this is an example of how we've done it before using ritualistic behaviors of interaction. So looking at how people are engaging with your app, your website, your call center, and building out personality indicators based on that. And the way that you do that is by first building out measures and quantifying habitual behavior in your customers. So you look at the consistency of their action and how consistent both what their action patterns are and the time frames of those actions. So does someone always log into the app on a Monday morning and do exactly the same thing? Their ability to plan. So do they run out of time when they're trying to finish things? Do they sort of run out of purchases that they make before they renew them, or do they always do it just before? How eager they are to interact with you and how eager they are to offer information when you ask for it. We then build out sort of scales for all of those measures and map the personality scales onto it, and then combine all of that to give a personality indicator based on this ritualistic behavior. So obviously you can do that on sort of a range of different data types across different industries, but sort of that's an example of how you could do it with interactions. And this is sort of an example of what an experiential engagement ritual could look like. This is someone who's going onto an app very frequently. They log in for different periods of time. They sometimes just sort of explore around the app and see what's available. They'll sort of go in, complete an action, and then not log off immediately. They'll still look around and see what else is there. They run out of time, so that sort of pattern of engagement gives you an overall view of the customer rather than just looking at, how often do they log on. It's a more behavioral sort of feature. And you can then take those behavioral features and build them into your models and predictors and get a more behavioral model out of your data. The second piece around real-time context monitoring. So at the most basic level, a basic but very useful thing is to have real-time dashboards to enable you to see whether people's behavior is changing, how your model's performance is either improving or degrading depending on context, and just keep on top of everything that's happening. We also find that having feedback loops within your predictor use case system is very important. And those, by feedback loops, I mean based on client interactions. So adjusting your models as clients interact with your system, and potentially updating things if you see that the pattern of client responses is changing. We like using multi-arm bandits in that context, but the key thing is having that client feedback loop built into your system. And that's also why it's very useful to have that real-time capability. And again, sort of like I mentioned before, to have sort of a very reliable, resilient backend system, because then your company can have confidence that it can actually put this piece into key client interactions and give you feedback based on that. And then the last piece is around, if you're looking internally instead of externally, how do you model complex systems and organizations? So we found one key thing is using network analysis to model exceptions flowing through the system, model work to be done, who's doing the work, then understanding and managing complexity as the organization changes and grows, and finally simulating the organizational structure. So in terms of network analysis, like I said, we found it to be a very powerful tool, both in terms of looking at users who are completing different tasks and how those all fit together, where they're bottlenecks, where there are people who are key, and if they're away for a certain period, or they get sick, or they resign, then it's going to be really damaging to the network and the flow of work through the network. Which tasks are most central and important? Looking at error propagation through the system, root cause analysis based on that, and what the impact of different errors is. Then something that I think is pretty interesting is around understanding and management of complexity in an organization. So as the number of customers and products and employees in an organization grows, complexity naturally grows with it. And that's not necessarily a bad thing, but it can easily result in growth in errors and costs in the system, and sort of out of line increases in work that needs to be done. So there's more work that needs to be done than there should be, given the growth that's been experienced or the change that's been experienced. And that's just sort of a natural thing that happens if you don't have any interventions being implemented. So what we found is very useful is to have sort of an ongoing, what we call complexity management loop, that is run as your organization is changing. And the steps that we found to be useful in that is you need data ingestion, translation, and categorization. So data to understand what's going on, understand that data, model what's going on, and determine the next best actions, and then implement a prediction that implement what is predicted as the next best action, and monitor what happens. And if you do that over time, you can manage that organization, that complexity effectively. And then finally, looking at analysis and simulation of organization structure. What we found is useful there is you need to build out archetypes of different types of people in the organization, how they interact, how people move between archetypes. Then look at how they all fit together, and how they share ideas and access across those networks. And what happens if you change the structure? How does the flow of ideas change if you change the structure? And then once you have that, you can build extra simulations on top of it. For example, looking at how innovation happens in the organization. So that's just an idea of what falls in these three areas. But I think the key point is that if you want to deal with the human in your system, you need to make sure that you have these three areas sort of worked out, and you have a sort of a theory and an approach for each of them. And that's what we focus on doing with our ecosystem.Ai product, because it's sort of takes a lot of different ranges of expertise to work it out. But it's a very interesting problem dealing with the human in the AI system. Thank you.
Thank you, Eric. That was so interesting. And I think we often just slap the tech onto the problem without thinking of the human side of the problem and the problems that we want to solve through this technology. I also just quickly had a look at the website ecosystem.ai. Fascinating. There's also a video that talks more about the offering. So I'd like to encourage all our delegates to head over there at some stage and check it out. Eric, thank you so very much. Everyone, we're going to have another 1 minute break, and then we're coming back for the next session.